By expressing 1 in polar form and using de Moivre's theorem, find the solutions to z to the 5 is 1 in polar form, with the arguments being between negative pi and pi. Well, we've always done that in previous examples, so that won't be an issue. So, z to the 5 is going to be cis 2n pi, where n is an integer. So using de Moivre, z is going to be cis 2n pi divided by 5. So it's just a case of now picking off our solutions. Now, with no particular order, I'm just going to call those solutions z1 through to z5. It's a z to the 5, a fifth order equation, so we expect 5 solutions. When you're in complex mode, you always get the number of solutions that you would expect from the equation. So taking n is 0, we just get cis 0. So that's going to be one of our solutions. Take n is 1, and we get cis 2 pi by 5. We don't need to think too hard about this because we know the separation between these roots is going to be 2 pi by 5. 2 pi in a circle, 5 solutions. Then if we take n is 2, we get cis 4 pi by 5. And then taking n is negative 1, we get cis negative 2 pi by 5. And then here we get cis negative 4 pi by 5. Now you might want to have z1 as being the one with the smallest angle and then go up the other way, but it really doesn't matter. Now remember that these are marked off in pi by 12s. So if we want to get this really accurately, and it probably will never be the case that you have to get this really accurately, then we want this to compare to the 12s. Now if this one is pi by 12, let's just mark that on there, that's 5 pi by 60. So this one would be 10 pi by 60. And this one would be 15 pi by 60. Then we've got 20 pi by 60. And so on. So this one here is going to be 24 pi by 60. And then this one will be 48 pi by 60. And then we'll have negative 24 pi by 60. And we'll have negative 48 pi by 60. And obviously these are not actually equal to this whole expression here. It's just the angle part I'm looking at. So 24 pi by 60 is just going to be a tiny bit more than that one. In fact, that's going to be 25 pi by 60 when we get to the next one here. So that's going to be fairly close to that one. Then this would be 30 pi by 60, 35 pi by 60, 40 pi by 60, 45 pi by 60. So our 48 pi by 60 is going to be in here somewhere. And don't forget that we've got the 1. And of course, I've drawn those in, but their modulus is too big. Everything's going to lie on the circle with radius 1. So that one's going to be there. And this one is going to be just here. And then we can just use the symmetry to get the ones in the bottom. So this one here is going to be sort of there. And this one here is going to be there. And they should be perfectly evenly distributed. Now in this case I actually labelled them, so this one Z1, Z2, Z3, and then we call this one here Z4, and this one here Z5. And as I say, you could actually label these so they go round in a numerical order if you want to.